Good morning, students. Now, this is my third session in the chapter Structure of an Atom. And in this session, we are going to discuss about the dual behavior of a particle, dual nature of a particle. Okay, my dear students. So, this session is also going to be very important session for all of us because here we will study that how a particle behaves like a particle as well as it has wave nature. So now, before proceeding to that particular topic of the dual behavior of a particle, first of all try to solve numerical problem on the basis of Bohr's model of an atom we have studied in our previous session. Just remember, in our previous session we studied that how we can calculate the radius, the size of an atom or radius of an orbit from the nucleus. Just remember that particular formula: Rn is equal to n square by z into 0.528 angstrom. This 0.528 angstrom is called Bohr's orbit. Okay, and for energy we had a formula: En is equal to minus 2.18 into 10 to the power minus 18 z square by n square joule. Okay, so these are the two formulas, and the difference between energy of the two orbit delta is E is given by the formula RH 1 by n1 square minus 1 by nf square. So using these three formula we will solve the numerical problem from this chapter first, and then we will move to the next topic. So now this is question, just what is the wavelength of light emitted when the electron in a hydrogen atom undergoes transition from an energy level with n4 to an energy level with n2. It means initially the electron is present in fourth orbit and finally it goes to the second orbit. So just I talk the formula third, that delta E is equal to RH 1 by n1 square minus 1 by nf square should we use. So delta E is equal to RH is Rydberg constant and its value is 2.18 into 10 to the power minus 18, 1 by 4 square minus 1 by 2 square. Okay, so when we will calculate it, 2.18 into 10 to the power minus 18, and the this will be 1 by 16 minus 1 by 4. Okay, so now further calculation is like this: 2.18 into 10 to the power minus 18, take the LCM, that will be 16, 1 minus 4. Okay, just then it will be 2.18 into 10 to the power minus 18 into minus 3 by 16, and it is solved, then we get value minus 4.087 into 10 to the power minus 19 joule. Okay, so this, the question is what is the wavelength of light emitted. In the question it was asked wavelength. So first of all we have calculated the energy. It means the light radiation which is emitted having energy equal to this much, minus 4.087 into 10 to the power minus 19. So we have a formula: lambda is equal to h c by E. You know that E is equal to h nu, or nu is equal to h c by lambda. So lambda is equal to h c by E. So we have h is equal to Planck's constant. Put the value of Planck's constant 6.6 into 10 to the power minus 34 into value of c, speed of light, 3 into 10 to the power 8 divided by just the value of energy we have calculated here. It is 4.08 into 10 to the power minus 19. So when you will solve it, 6.6 into 3 into 10 to the power minus 34 into 10 to the power 8, and then it will be, it should be written here 10 to the power 19 divided by 4.08. After final calculation, we will get the value 486.3 into 10 to the power minus 9 meter, or it is equal to 486 nanometer, because 1 nanometer is equal to 10 to the power minus 9 meter. Okay, student, got it? So in this way you have to solve the numerical. So this was the first numerical. I have solved it. It is already solved by me. Now moving to the next numerical. Just see how much energy is required to ionize the hydrogen atom if the electron occupies n is equal to 5 orbit. Compare your answer with the ionization enthalpy of hydrogen atom. Energy required to remove the electron from n is equal to first orbit. My dear students, here what is what is given? Already electron is present in fifth orbit. Now when you are removing an electron from the fifth orbit, it means the final orbit will be infinity. You know that since electron present in fifth orbit, its energy will be less than the infinity. At infinity, energy of electron will be 0. So now in order to calculate how much energy is required, it means just that difference of energy between infinity and energy of the fifth orbit. So how will you solve it, this numerical? Just see, we have a formula for energy. En is equal to minus 2.18 into 10 to the power minus 18 into z square by n square. Okay, and the difference is delta E is equal to, you know that here electron is removed from fifth orbit, so the final orbit is infinity. So what would be the energy at infinity? E infinity minus E5. This is the difference in energy, and that much of energy is required to remove electron. Is it clear? And you know that at infinity the value is going to be 0, so this part can be written as 0. So you can say that delta E is equal to 0 minus E5. So now what will be the energy in the fifth orbit? It will be minus 2.18 into 1 by 2.18 into 10 to the power minus 18 into 1 by 5 square. So what will be the value? Just minus minus plus, 5 square is 25, 2.185 is divided by 25, so it will be 0.0872 into 10 to the power minus 18 joule. This much of energy is required to remove electron from fifth orbit. Is it clear? So this is delta E. Now it is asked in the question, compare your answer with the ionization of enthalpy of hydrogen atom. So you know that the hydrogen atom electron is present in the first orbit. It means in that case n1 is equal to 1 and nf is equal to infinity. Again try to find the energy difference between these two. Delta E is equal to energy of infinity minus energy of the first orbit. Okay, again this energy of infinity is going to be 0. It means energy difference is equal to minus 2.18 into 10 to the power minus 18, okay, into 1 by 1 square. It means here delta E is equal to minus 2.18 into 10 to the power minus 18 joule. It will be positive. So here it is said that to compare your answer. So what is the energy difference between these two? Just take the ratio. If energy in the first case, that is when electron is removed from the fifth orbit, delta E, if it is represented just like E, delta E5 is equal to 8.72 into 10 to the power minus 20, and from delta E1 it is 2.18 into 10 to the power minus 18 joule. Just take the ratio, you will get 0.04. So less energy is required to ionize an electron from the fifth orbit. Just see, 8.72 into 10 to the power minus 20, and from the first orbit the energy required is 2.18 into 10 to the power minus 18. So less amount of energy is required to remove electron from fifth orbit. Is it clear? Okay, so I think that just these two numericals have clarified your concept. So moving to the next topic, what are the limitations of the Bohr's model? My dear students, there are some limitations, and at the end of the session we will study what are the cause for the failure of the Bohr's model. So limitation of Bohr's model is it the Bohr's model was unable to explain the spectrum of atoms other than hydrogen. Only a spectrum of hydrogen was explained with the help of Bohr's model. This model was not able to explain the spectrum of the other atoms, unable to explain the splitting of spectral lines in the presence of magnetic field, that is called Zeeman effect. This model was also unable to explain the splitting of light in the electric field, that is called the Stark effect. It means these two effects could not be explained on the basis of the Bohr's model. Okay, it could not explain the ability of an atoms to form molecules by chemical bonds. So these are the limitation. These points could not be explained on the basis of Bohr's model of atom. It fails to account the finer details, doublet, triplet, that is closely spaced lines in the spectrum. Just see here in this picture, this is a single spectrum line observed, but when it was observed by a spectroscopic technique, highly advanced spectroscopic techniques, you can see there is the finer lines also observed, doublet is observed in that particular spectral lines. So these points could not be explained on the basis of Bohr's model of an atom. So it is what it was required to move forward to think about the other model of an atom. And finally we are moving towards the quantum mechanical model of an atom. That model of an atom which was given by Erwin Schrödinger in year 1926, and this model of an atom is based upon the two important principles for the development is required. It based upon the dual behavior of matter and Heisenberg uncertainty principle. So these are the two important principles which was used to develop the quantum mechanical model of the atom. So first of all we will study about these two principles. First of all, dual behavior and Heisenberg uncertainty principle. So dual behavior of matter, my dear student, this was given by proposed by in year 1924 by French physicist de Broglie. De Broglie has given this concept that matter exhibit dual behavior. Dual behavior means particle like behavior as well as wave like behavior. And then he said that electron is having momentum as well as wavelength. Momentum is corresponding towards the particle like behavior, and wavelength is just corresponding towards the wave like nature. So de Broglie derived a relation between wavelength and momentum for a particle, and that particular relation between wavelength and momentum is written as lambda is equal to h by mv. So now I am going to derive this mathematical relationship between wavelength and momentum of a particle which was given by the de Broglie. Just see, my dear students, if there is any doubt, just tell me. You can convey message me. Now we know that from Einstein equation we know that E is equal to energy is equal to mc square. This is the first equation. From Planck's quantum theory, I have already told you, from Planck's quantum theory you know that E is equal to h nu. So now equating these two equation, you will get mc square is equal to h nu. Okay, and you know that nu is the frequency and nu is equal to c by lambda. Just put this value, nu is here, so mc square is equal to h into c by lambda. Now lambda should be bring to the left side and c square to the right side. You will get lambda is equal to hc by mc square. One c is cancelled out here, so lambda is equal to h by mc. C is the speed of light. If c is replaced by the velocity, so you will get lambda is equal to h by mv, and mv is momentum. Product of mass and velocity is called momentum, so lambda is equal to h by p. This is the relation that is called de Broglie equation, given by de Broglie in year 1924, which correlates the particle nature. Momentum is for the particle nature and wavelength is for wave nature of a particle. Is it clear? My dear student, there are some numericals also given in your NCERT book on this particular topic. So all of you should have remembered the statement of the de Broglie equation first, and then how to derive the mathematical formula for de Broglie equation. I hope the concept is clear to all of you, and all of you have got the clear cut concept why the behavior of an electron is considered as dual nature, because lambda, wavelength as well as momentum both are correlated, both are related with each other. Okay, so in order to develop the quantum mechanical model of atom, two important principle is required. One is dual behavior, that was given by de Broglie, and second was Heisenberg uncertainty principle. So now moving to the next part, that is the Heisenberg uncertainty. These are the formulas already derived by me. So moving to the next topic, that is Heisenberg uncertainty principle. My dear student, as the name suggests, Heisenberg, it means it was developed by some scientist whose name includes Heisenberg. Absolutely right, and the name was Werner Heisenberg. And year 1927, he stated that what he stated about his principle: it is impossible to determine simultaneously the exact position and exact momentum. Momentum means velocity, because mass is fixed. Velocity of an electron is not fixed. So what does he want to say? What is the conclusion from the Heisenberg uncertainty principle? It is not possible for us to determine simultaneously. At the same time, we cannot determine the position as well as velocity. Suppose if we want to specify the position of an electron, that electron is present here at this particular place, then at that time you cannot predict its velocity with accuracy. And suppose if you want to explain, you want to determine the velocity with accuracy, then your accuracy in position could not be 100% accurate as you want. So there will be uncertainty in position as well as in velocity. It is not possible to determine them simultaneously, that your position is also accurate and the velocity of electron is also accurate. It means, what did we learn in the Bohr's model of an atom? That an electron is revolving in a particular orbit with some given velocity. So in Bohr's model of atom, we are calculating the exact position. In Bohr's model of atom, we are calculating the velocity of the electron. But after studying the Werner Heisenberg concept, that it is not possible, it means that the concept of that particular circular path is totally wrong. So what is the mathematical expression given by the Heisenberg? That delta x into delta px. Delta x means uncertainty in position. Delta x is equal to uncertainty in position, and delta p is equal to uncertainty in momentum. So what did he say? What was the mathematical expression? The product of uncertainty in position and the momentum is always greater than or equal to h by 4 pi. Just remember, in Bohr's model, the angular momentum is equal to integral multiple of h by 2 pi. But here the product of uncertainty in position and uncertainty in momentum is greater than or equal to h by 4 pi. And now you know that momentum is equal to mass into velocity. So this expression can be also changed like this: delta x in place of delta px. Now why is it is written px? It means in the coordinate axis, in the x direction. Momentum is in x direction. So in place of delta px, just I have written delta m vx mass is fixed, so it is constant value, it is just shifted to the right side because h is constant, pi is constant, and mass is also constant. So now the uncertainty in its position, uncertainty in velocity, these two are, the product of these two are greater than or equal to h by 4 pi m. So my dear student, this is the final mathematical expression for Bohr's model. So for Heisenberg uncertainty principle, where delta x is the uncertainty in position, delta vx is the uncertainty in velocity. Just try to get some conclusion from it. If delta x is small, suppose if you have written delta x into delta v is greater than equal to h by 4 pi m. If delta x is small, it means uncertainty in position is small, then the velocity will be uncertain. And if delta v is small, then the uncertainty will be in the position, delta x will be large, because the product of these two should be always greater than or equal to h by 4 pi m. So what are the significance of uncertainty principle? We have to get the significance. So the first significance is that because we could not find this position and velocity with significance, with accuracy, so the first significance of uncertainty principle is it rules out existence of definite path or trajectories of electron and other similar particles. Rules out existence of definite path, that is existence of orbit. For a subatomic object such as an electron, it is not possible simultaneously to determine the position and velocity at any given instant to an arbitrary degree of precision. So these are the two. Third significance is what? The precise statement of the position and momentum of electrons should be replaced. Till now, what are we saying? We are saying that electrons are evolving in circular path around the nucleus, but now this sentence, this statement should be changed. What should be say about the electrons? That probability, the word probability which is highlighted here, that now the probability of the electron at a particular position is maximum or minimum. Okay, so my dear student, after studying these two principles, that dual behavior of particle and the uncertainty principle given by Heisenberg, we can easily say that what are the reason for the failure of Bohr's model. So these are the points. See, in Bohr model, an electron is regarded as a charged particle moving in well-defined circular orbits about the nucleus, around the nucleus. This is the reason, because Heisenberg uncertainty principle stated that we could not find out position as well as momentum simultaneously. In Bohr's model of atom, the wave character of electron was not considered, only the particle nature was considered. An orbit is a clearly defined path, and this path can completely be defined only if both the position and the velocity of the electron are known exactly at the same time. So the third point is totally it is opposite of Heisenberg uncertainty principle. So this is the main cause for the failure of Bohr's model of atom. Bohr model of the hydrogen atom therefore not only ignores dual behavior of matter but also contradicts Heisenberg uncertainty principle. So in nut and shell we can say that why the Bohr model was failure, because of not considering the dual behavior of the particle, because of not considering the uncertainty principle. Since these two principles were given later on in year 1924 and 1927, while the Bohr's model of atom was given in year 1913. So after these two principles, we will study about the quantum mechanical model of an atom where the dual behavior of electron was considered, and the special word probability will be introduced, that now we are going to use probability. So my dear student, I hope the concept has been clear to all of you. So that's all for the today's session. I hope the concept is clear. Okay. So So thanks for watching. Like and subscribe my channel, and share my blog, share my channel also to all those students who are needy and they want to learn. Okay, thank you, have a nice day. We will study about the quantum mechanical of model in our next session. Thank you.